Okay, again, as of today, we'll proceed with our pre-lab. Pre-lab on PSIM, introduction PSIM. Because we have a lab, actually, previously we have mixed between hardware and software. Software-wise, we have used lab boot for simulation on the machine, DC induction and synchronous machine. But due to current constraint, we have moved to fully online on our labs. So hopefully, and only the available software that can be used throughout the lab is PSIM. We have tried to use or make use of MATLAB Simulink, but unfortunately the issue on license, which hiccup or on hold the process, so we moved to the PSIM instead. Okay, and as of now, we need you all to, we hope you have download PSIM software and you have able to access to the simulation. So if you refer to module pre-lab number 1, we have here introduction to PSIM. So our aim or objective for this subject or this lab actually is to introduce you all to the how to use PSIM. This PSIM will be used not only in this lab actually, but will be used throughout your other subject as well. Especially if you went to EET 307 Electronics in semester 2, you also will use PSIM. And I believe other subjects also have moved to online simulation software, and PSIM is most user-friendly that match the other lecture we use as well. Okay, the objective of this pre-lab module, we hope at the end of this lab you are able to use PSIM in general, especially on our subject is to simulate, to design, compose, and simulate, and also analyze the circuit for electrical machine control and characterization. Means that you are able to compose the circuit on how to simulate how the motor can be run and how the motor behave when we adjust any kind of parameters that involved in the control. So in this subject or lab session, we'll have about maybe 20 minutes or up to 30 minutes of briefing. Then I will let you perform your labs, and then I will check on you before we dismiss. Okay, we have 2 hours of lab, so around 30 minutes, maybe up to 11:30. I'll do some briefing. If you have any Q&A, you can ask me because I'll be here. You can offline to save your data or your credits. If you are on free Wi-Fi, you can stick online. And I'll check you again maybe 30 minutes before we leave and before we dismiss, maybe around, because our lab will end at 1 o'clock, so 12:30 or 12:45, I will check on you. If there's nothing to highlight or to discuss, so we dismiss, you continue with your lab and you submit your lab throughout online. You can copy this module and you fill in all your results here. You can paste, you can snapshot your simulation, paste on the on this module, use as your answer module template. And waveform plot, you can plot here, all here. You can perform discussion on this paragraph as well. And must take note that at the end of paragraph, we put you some marks portion. So the marks actually represent how much or how long your discussion should be. Maybe 1 marks represent 2 paragraph, or no, 2 lines of answers. So 3 it means that maybe you have to fill in about 6 lines of discussions. Okay, at the first page for section 1, you can see over here. If you have any issues, you cannot see the screen or blanks, please voice out. Okay. Now I'm presenting lab modules 1, pre-lab modules for introduction to PSIM. Okay, if you see at section 1, voltage, current, and power plots, what we need you to do is that by referring to appendix A, attachment of this one. So this is what the expected result you should have on the waveform. Okay, you use this parameter. You need to do is what you need to do is that you have to plot 2 cycles of output, which you use the source, AC source of 50 volt peak parameters, frequency set at 50 Hertz. And let's say if you use that source for resistive load, so the value of resistive value is 5 ohm. For inductive, 10 millihenry. For capacitive or capacitor load, you use 2 millifarad. And impedance is a RL load, resistive plus inductive load, 5 plus 10 millihenry. So you write, draw your schematic inside PSIM, copy and paste here. Okay, the waveform plot should be in 2 cycles. Okay, 2 cycles. Means 2 cycles if you set at 50 Hertz of frequency, so 1 cycle means 0.01 and 0.01 second and 0.02 second. So 2 cycles means that 0.04 second. So when you plot, you jot down the result that you measure inside your simulation in terms of peak value, average value, and RMS value in terms of voltage, current, and power. Okay, you can repeat the experiment on inductive, capacitive, and impedance load. Then you discuss what you observe throughout your simulation. Okay, in B, what you need to do is that because within PSIM we have a box or the application on the machine as well. How you want to simulate machine and how you want to analyze the behavior and reaction of the machine. Okay, we have a reference or the parameters. If you click them on the machine itself, comes out with this default parameters lah. So you don't have to change. You just run with the default parameters. What you need to do is that you have to include, or you have to simulate and present your observation up to 10 seconds of simulation time and 10 seconds of simulation time, because you are simulating DC motor. So DC motor we don't use AC source, which include or we have to include the frequency reference. So instead of you set at how many cycles, you set at 10 seconds simulation time. So you use source DC of 120 volt setting and simulate on 2 parameters, which is minimum top value of 1 Newton meter, and another scenario is that on the 100 Newton meter setting. Okay, this is the basic circuit that you should compose now. I'll show you later on how to select the circuit or the device and the blocks. Okay, the waveform you need to plot is that you have to select in terms of how you want to present your result, and so it's up to you to present your results. Is it you want to combine all the graph on one template or one screen, or you prefer to separate? So it's up to you. So in terms of discussion and conclusion, you have to discuss now. So we put here 4 marks, with that you have to list down, or you have to discuss in terms of your observation at least 8 lines. Okay, then you conclude overall lab module regarding PSIM and simulation on the DC machines. Okay, we go to the simulation. If you open your PSIM later on, or you can open now. So in between, is anybody have any things to say? So please voice out. Any concern or any question, please voice out. Okay. So if you open your PSIM, you click at new. So you will have a white display like this. So all the top labels here, we have a drop down items. So if you want to simulate, so you have to create a circuit. So let's say we are composing the first basic circuit of an AC source to supply resistive load. So you can select the component down here. We have here all of the component resistor, basic things inside our simulation: inductor, capacitor, switch, into of power switch, signal generator, voltmeter, ammeter, scope, all we have here. Or we can select from the elements this here in terms of power elements, control elements, or other things that we need to use in our simulation. So for our basic simulation now, we need to have a AC source. So sinusoidal voltage source, click and place. Then we need a resistor, click and you can rotate. If you right click on your mouse, you able to rotate. So we click and place here. Then we select our connector. Just draw and release. Click and release. So you click and you release. So you have a complete circuit of source and load. Now if you want to measure, so you have to put measurement device, which is voltmeter. So voltmeter you should place in between terminal of your source. So you click between live and neutral, or positive and negative source. Then if we need to measure current, so we need to cut the wires and put our ammeter. Okay, we can complete our circuit. We double click on the device, it will show us what are the default value. So resistance default value for this device inside our PSIM, for my version, which is 9.0. I'm not sure have you have download the latest one or not, but for this version, I have it stated here 12 ohm. So we need only 5 ohm. So you click 5. If you want to display, you can click display. You display here 5 ohm. Then our source, we need 120 volt. So now the default value is 220 volt. We change to 120 volt. Frequency 50 Hz, okay. Other you don't have to change. Okay, we have here source, load. So we complete the circuit. So you can click to copy to clipboard your circuit here and put inside your report. Okay, then if you want to simulate, we can. Okay, another one is that your simulation control, you have to select the simulation control to determine how long you want to run your simulation. So time step maintain here. Total time is 0.01 in default. So you need only 2 cycles, which is 0.04. You can run more than that, but in terms of presentation, we need you all to, you can squeeze or you can take only 2 cycles of simulation and paste inside your report. In terms of run, you can run the further the time we run, the stable or the correct value we able to anticipate from our simulation. Okay, let's say we just run for 2 cycles. So we can select here simulation control, run simulation. After simulation complete, we run SimView, or we can select from the shortcut here itself. So we can run simulation. So once your simulation is complete, it will show you the value of current and voltage. You can display separately.
Saya tak nampak present ke line saya yang slow
You tak nampak mana? You nampak graf yang saya generate ni?
Tak, saya tak nampak.
Slow kot.
Saya tak nampak apa-apa.
Kejap saya present semula. Okey, nampak tak?
Tak nampak ke?
Wait entire screen. Nampak tak?
Tak nampak ke? Saya tak nampak juga. Ke line saya yang lambat?
Tak
Tak nampak tak?
Window. Nampak sekarang?
Nampak saya, nampak. Baru nampak.
Nampak saya.
Okay, nampak PSIM
Nampak dah.
Okay. Sekejap. Okay, line. Okay, I'm presenting now the PSIM page. Okay, PSIM page. Okay, sekarang kita we design, for example, circuit for source to supply resistive load. Resistive load is 5 ohm. Source we set at 120 volt. So the simulation control, if we double click simulation control, it will shows us the how much the time step of the time. So we set at 0.04 setting. Okay, when we click on this point, you can see this is run simulation. If we click run simulation, it will show us you can see not the graph. Nampak graph tak? Graph.
Tak nampak tu.
Tak nampak Oh, saya share. Tak nampak graph
Tak nampak.
Okey, jap. Window. Saya kena present window ni, tak present screen. Okey, nampak graph?
Nampak.
Okey. Okey, ini bila kita klik dekat measure. Oh sorry, bukan measure. Dekat ni. Dekat analysis. Kita boleh pilih sama ada kita nak either we want to present in individual current and voltage, or we can lump together on the same screen. Let's say we put together voltage and current on the same screen, so we can have the same screen on voltage and current. So once we got our result here, we can use same like in the circuit just now. We can copy to clipboard and present in our or paste in our reports. So here also you can edit or you can adjust the curve, style, color, label, size or whatsoever lah. It's up to you. If you want to present, you want to enlarge the size, so it's up to you. You want to change the pattern, it's up to you. So this is basic result that we get from our simulation. Okay, now this is the result of current and voltage. What about power? So power for DC, P is equal to VI. So how you want to get the result of power is that you click on the screen, you can use here the result of current times voltage. Then you add to the screen. Then you will get the value of V times I, which is power. If you measure, you click measure here. So we measure if you click measure, it will show you the box of what are the current measurement of this line. Or you can click here, it measure the peak value. You can click here, it measure the average value. You click RMS, you measure the RMS value. So you put all the measured reading here to your result. Okay. So you can repeat the same step for capacitive and inductive load. Then you put a comment on your observation. And then you go to phase B. And phase B, which is simulation on the motor. Simulation on the motor circuit. Sorry ya. Where was it? You can see my PSIM on the motor circuit. Nampak?
Nampak, sir.
Okay. Okay, macam mana kita design the motor circuit here is that, okay, start with the source. So we need DC source. You can select here the DC source. Then we want to power up our motor. So you select the elements, which is motor drive module. So we select our DC machine. Come out like this. So we complete the circuit from source terminal to the motor terminal. You connect in terms of shunt connection, parallel. Okay. Then the motor we need to power up or we need to drive a load. So this is free running, so we need to connect a load. So you put a load, elements, power, motor drive module, mechanical load and sensor. So you select a constant torque load. Okay. Then we complete the circuit. So you can run already your system. But we need to have a reading in terms of how much the voltage we apply and how much the current that pass through the circuit. So motor and the magnetic field, they share the same voltage terminal, so 1 voltmeter is enough. But in terms of current, we need to have a different measurement ammeter. So in between your motor and your load, we need to measure their torque and their speed. So in the shaft itself, we should put the measurement elements. Okay. We need speed sensor and also a torque sensor. Speed sensor, and another one is your torque sensor. So we put a floating voltage measurement here and here. So it will reach the speed and the torque. So this is the same circuit like we have inside our modules. So you can label your ammeter here to indicate or to this differentiate between the current that flows to the motor and the current that flows into your control circuit or magnetic field circuit. Okay, this is your speed sensor. You can put as a speed. This is your torque sensor. So this is the constant torque value that you will need to adjust either on setting of 1 Newton meter or 100 Newton meter. Okay, let's say we run at 100 Newton meter. So run simulation. So it shows, or you will have your results. You can see the properties table now that appear on the screen.
No, sir.
Nampak ah? Okay, wait. Before we simulate, we need to adjust or edit the simulation control total time. So we put here 10 milliseconds and we run. Ten seconds, sorry, 10 seconds, not 10 milliseconds. Second. After time. You put 10. So once it's run, you can click. Once you complete the simulation, you click here. So you click at Run Sim View. Where is the screen? Sim view. Okay, once you click sim view, you have a generated graph like this. So I'm not able to share on how the pop-up table come out just now. But once you generate your result will come like this. If you share the same lines on the same frame, let's say I3 and I1 share the same frame, so you have both lines here, red and blue here. If you share V2 and V4 here, so you have your lines like this. So it's up to you. You want to present, is it on the same graph, or you need to segregate the graph, because if you measure, it has some value here. This I4, we have value, but if you share the same graph, because I3 is too high, so you cannot appreciate I4. So you have to separate. And same goes to V3 and V4. V3 we have value, same to V4, but because of V3 is too high, so V4 you cannot see the response. So it's up to you. You want to lump all together, or you want to separate. So it's up to your on your justification. Okay, that's for part 1 and part B of your result. And so as of this pre-lab, we just want you all to familiar with your PSIM. The real experiment on behavior of your motor will be conducted on the lab 1 and onwards. So as of now, any question from the floor? If there is no question, I will let you all perform your experiment, and I will check on you half hour before we leave, half or 15 minutes before we dismiss. Okay? I'll be here. Anything you can raise out, or you can message on the text box. Okay? Thank you. Please proceed.